And so Umesh asked me to do this, to moderate this panel, I think because I'm a vision guy, so I have healthy suspicion of language. And so I'll be a little bit adversarial. But I hope that we will get, and I'm actually pretty sure that we will get the speakers to disagree with each other, which is usually what makes for a good panel. So let me start with the first question, which is, so LLMs right now are like these eager, bookish teenager. They are they are just going through, binging on 4 millennia worth of written cultural history. Okay, and 2 questions. First, when do you think they will finish going through all of the data that is historical text data available? When will that happen? A second question, what will happen after? Will our performance plateau? What would be when that fire hydrant worth of data turns into proverbial trickle, and also probably poisoned by some of this generative text as well? What will happen next? Whoever wants to start.
So just a clarifying question, are you referring to just language data or all data?
Language data. No, language data. Yeah.
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 Yep.
Okay. Yeah, so, I mean, people, I think, disagree quite a bit as to sort of how much useful language data there is out there. I mean, on the one hand, it seems like you can kind of think that models are already training on most of the good data that's out there. In another sense, there's obviously sort of hugely more data available, sort of buried in every kind of corporation and data store. But, you know, presumably getting less and less incremental value from it. So, I mean, I think that the first, you know, notwithstanding the phenomenal amounts of money that OpenAI and Anthropic predicts spending on next generation models, I actually kind of think the first thing that's going to run out is useful data. And so that will put the brakes on progress. But I think this is an enormous opportunity for machine learning, because I think the really important thing to remember is that even though these huge models like GPT-4, whoa, they're fantastic, the reality is that at this point, they're learning on about 100,000 times as much data as little humans get before they're productive language users. And so that suggests that they're not actually very good machine learners, and that there's still just huge opportunity to come up with better machine learners in future years.
You might actually know how long you have left.
You know, it's a great question. For obvious reasons, I can't go into too much details in what I'll say, but I think we will discover that it is possible to continue to keep making progress despite those real obstacles.
At least for the, is this okay? Good. At least for the data side, I think there is a lot of copyright data. If the government allows us to use copyright data there, at least I think there is 1,000 times more. I don't know, just random guessing. I don't know.
I just wanted to point out that, you know, there's some tension between the two things you said, which is that current learning is very inefficient by some very large factor, and that therefore more data would not help. To me, that it seems the opposite. That when you begin to learn more efficiently, maybe you'll squeeze more out of the same data. That seems completely plausible.
That's what I was meaning.
Is that what you meant? Okay, sorry. Okay, I didn't. So therefore, you don't run out of data in that sense. Yeah.
That's why you said there's more opportunity for
What about all of the data that gets generated, that is fake data, basically?
Yeah, so just completely speculating what OpenAI or other companies may or may not do in the future. I kind of feel like they might find a lot more data that they haven't, or some companies haven't discovered yet. But plus, I suspect that AI synthesized data might be a lot more enabling, not only for the small models that I tend to train. Which also was based on synthesized data after all, but also for training the larger models going forward. But of course, I can only speculate. Thoughts?
It's going to be, there is a risk of a slightly boring panel. What I'll say is I think that many of the ideas that were presented just now were all quite sensible and plausible.
Okay, a little follow-up. So again, a lot of the talks today were about algorithms. I want to push more on the data side. A lot of the speakers said, well, I don't know if there is this and this on the internet, right? So it seems like it would be very useful to actually understand not just algorithm, but understand the data, understand what is there in the internet. For example, are there tables of 3x3 multiplication somewhere in there, or maybe even 4x4 tables, right? What is the, how can we basically disentangle this, high dimensional interpolation capabilities, which are quite impressive, from the true generalization, actually, creating something that wasn't there before. How do we understand the data that's out there to actually disentangle those two things?
So I'll mention briefly in my talk tomorrow that you can just do a random sampling approach. Like basically, you start with only the generative setting. Like you start with a list of n skills, or whatever you can call it, reasoning and linguistic skills, and you can randomly sample k of them, so like 5 of them. So now there are n choose 5 combinations, and then you can pick some very esoteric topic. You can put constraints on it, like the topic is baseball in the Caribbean or something. So it's a fairly small part of the internet, and then you can ask the model to generate text on it, and if it can, then it shows that it's at least imagining a situation using your constraints, which doesn't exist in the data with high probability. And that, GPT-4 does pretty well in my testing, and the other models struggle a bit, but they also do it to some extent.
So if you're not in the morning session, I talked about how GPT-2 off the shelf is completely hopeless. But if you're really willing to look out for a good hidden samples that GPT-2 actually is capable of generating, it's just that it's not willing unless you somehow put more decoding algorithms on top or other strategies on top. And it doesn't know that it should assign high probability to it, but technically speaking, it's capable of generating them. And so if you discover those, then you have a good reward model or filter model that can assign good scores to them, then that serves as AI synthesized data that AI can feed on. So that's a bit of clarification on why I said earlier that AI synthesized data could be really enabling, because inherently the generator is capable of generating them. It just doesn't know that it should assign higher scores for them yet. And so that requires a bit of a human intervention. But having said that, although maybe even GPT-2 may have like this infinitely many strings that it's capable of generating, in my experience, especially thinking about common sense reasoning, coming up with really corner case that even GPT-4 cannot handle, it's not that easy to systematically somehow generate all these weird corner problems that, nobody actually think about, but maybe, for the purpose of making a talk, I might cook up something. So in that sense, it seems that there's a fundamental limit as to how exhaustively can you pick a data set and then really exhaustively enumerate them all. So
I have a comment on this as well. I think it's a very deep question, like how much do the models memorize and how much do they generalize? Can everything they do be reduced to memorization? I think it's a very valid question. And I would like to offer a way of thinking about it. One thing I'll say is that our standards for what constitutes memorization have been increasing over the years. There was a time where language models used to be n-gram models. These models have not been used for so long that it's possible that many of you here have never heard this word before. N-gram models. Those are models which basically they say, I'm sorry, I didn't hear what you said, so I don't know what the joke was.
We're not as young as we look.
I mean, it's tough out there. But those models would predict text by finding an exact phrase in the training set. So it says, okay, so you say, I'm going for what comes next? And it's going to say, well, let's look at all the occurrences of I'm going for in the text and see what we find. Now, more than 10 years ago, Google would already train n-gram models on trillions of words. And they would still find that you have, like, the n-gram model would suffer from the curse of dimensionality. The curse of dimensionality is something which was also commonly mentioned in, for example, high-dimensional statistics contexts before deep learning, I would argue, solved it. We no longer mention the curse of dimensionality anymore. Our context lengths now are in the thousands, and we are totally fine, and we can usefully benefit from them. So something clearly very different is happening. I want to mention one other thing about memorization versus not memorization, and this is the difference in performance in the different generations of models. It's true that the information about like how much data those models were trained on isn't exactly public, but you can kind of make an educated guess of like an upper bound of the increase of the amount of data. And you can say, okay, if you go to the previous model and it clearly couldn't do some things, and you say, yet the next model does them, and it does them because of memorization, it must be that like, okay, so would an n-gram model succeed if it was trained on the same data? The answer is obviously no. Also, like when we say memorization now, you say, oh yeah, like if it paraphrases the idea in a totally different way, but it's the same idea, it counts as memorization. I think it's a stretch. But it is true that these models are definitely non-human in the way they learn because they need so much more data. They are not human. Their generalization is not quite human yet, while also being surprisingly human-like in their representations and errors in many, but not all ways.
Yeah, just to follow up on this. Don't you think that transformers are actually quite related to n-gram models? Basically, if you think of an n-gram models with a dynamic n that is kind of input specific, it's not really that far of a jump.
Absolutely and emphatically no. Absolutely no. Like a transformer is a computer. It is a computer which does parallel computation. It is a computer that is programmed automatically with gradient descent. It can like run algorithms on the inside. It is a completely different kind.
One could say that n-grams could run very simple programs too by lookup, kind of Chinese room argument.
No, I don't think so. Because the Chinese, like the thing is, okay, so the mechanism of the n-gram algorithm, there's no algorithm there, pretty much. It's like you look the thing up, and if it's there, you're good. The neural network does the actual computation. So indeed, the Chinese room argument requires an exponentially large. Like keep in mind, like I feel like in in early CS education, they really stress the difference between exponential and polynomial. And I feel like we kind of forgot it. You know what I mean? Like an Engram model, for it to be good, you need like legitimately an exponential amount of data, like 2 to the 700 tokens, maybe something like this, 2 to the 500. I don't know, like something of this order. It's like it's a different universe.
Maybe I would like to add a little bit on the, whether how much of it is memorized versus actually generalized. So when I look at even GPT-2 output, I felt that it's generating things that's not quote unquote completely memorized, but generalized. So there were some novelty in it for sure. But I wonder whether there are two wildly different types of novelty or creativity, such that there's more of interpolation type novelty where, you've never seen maybe avocado chair before, but you've seen avocado and chair, and then able to combine both of them in a brand new, way. And similarly, you ask weird questions to ChatGPT that presumably no one else asked about, but it's able to make some interpolation between the lawyer-style language that ChatGPT tends to speak with the particular content that you provided with, so that it's doing some brand new output that may have not existed in the training data. But having said that, hypothetically, I wonder if there's a really different level of novelty, like, for example, Hemingway writing Hemingway-style novels for the first time in the humanity before anyone else done so. If hypothetically OpenAI removes all of that from pre-training data, and then somehow prompt engineer GPT-4 or 5 or 6 that please write in a brand new style of writing, and try to encourage it to win some like a prize, whether it's going to be able to really come up with something genuinely novel. And by the way, of course, these are difficult for humans as well. It's not just for GPT, whatever that's difficult. But similarly, like a major breakthrough with theories, maybe it's a more question for you, but do you envision that, or for anyone else in this room, this sort of a novelty can be achieved through the sort of unsupervised learning that we're currently doing?
Maybe actually that connects with my next question, which is kind of following on that, and it's goes to be a little bit more philosophical, but Chris's talk gave me permission to be philosophical. So Chris mentioned that it's bacteria to Bach, right? And the thing is that if you think about it, language is evolutionary. The last 5 minutes of development, right? So most of that thing was done before language. So in a sense, what we are doing right now is we're kind of chugging away the bacteria and basically starting directly with Bach, right? And so, is this okay? Are we okay with basically forgetting about Darwinian intelligence and going directly to Eugorian intelligence, kind of skipping all of the fun stuff? Because in a sense, I would think that, Bach became Bach because, his ancestors were, hunting and gathering and had pain and suffering and were, developed language eventually and tried to communicate through language and from music, that pain and suffering. Isn't that kind of needed to get to this true generalization that we're talking about?
Yes. It's sort of hard to know with the pain and suffering and if those have or will ever have any analog with digital devices. But I do subscribe to, this following duality. On the one hand, it's been just amazing how much can be achieved from nothing but a language model. I think almost no one thought possible how much you could do with simply building a model on a huge amount of language. It's just been way beyond everyone's expectations. But on the other hand, I think it's clearly not enough. And you could even believe that if your future AI, like a kid, developed first some better models of causality that come from the kind of stimulus response experiments that little kids do with their towers of blocks and things like that, that would actually give them a much better basis for doing the kind of causal modeling of the world that I think that will be necessary to get beyond the almost entirely associative learning that's done in transformers.
Having to read the entire internet does sound like suffering.
Personally, I don't think those experiences not related. There is people who is blind, cannot see and cannot hear and can still be intelligent and
Their
also,
ancestors suffered though.
yeah, but they don't really carry those memories from them. At least I don't know any suffering that make me know how to do math. And also I feel to be creative, I think one barrier of creative is someone need to able to know what is a good idea and what is a bad idea. And I think that the current GPT one problem is just it cannot tell between good and bad sometimes, especially if it will involve reasoning. And if it can start verifying it, I feel GPT is like P versus NP. If it know how to NP, then we can start brute forcing and then maybe it can solve Riemann hypothesis one day if it can tell between a good proof versus bad proof.
Yeah, just to point out the obvious, I mean, if you have these agents embodied in some way and then they're training on the experiences, then basically you're getting there. So,
But that's exactly what we are not doing.
at this point, primarily probably for AI safety reasons rather than any other reason, I would guess. Probably that could already be done.
I think we just don't have as much of a public data. I mean, the thing about language is that internet happened, and then we all contributed to that repository of language in large quantity. But we sometimes do share photos and videos, but not anywhere close to the amount of text out there. And then for more like robots, the manipulation and all that, it really requires a little bit more personalized, different kinds of visual signals compared to the photographs that you take in a very selective way in your life. So the nature of the data, there's some gap between, or significant gap between what's actually freely available on online versus what we might really need if we were to train these vision and robotics models in the way that LLMs are trained. What I mean by that is right now it's a little bit like a brute force on a lot of human data, and then we try to sort of like bypass bacteria and go straight toward the bug. But that recipe seems to require a lot of data available, and there's a data bottleneck with multimodal models.
And I also think the one problem of those image data is they are less information dense compared to text. In some sense, the internet, the information is already not very dense. Most of them are junk. But if you look at the image data then, or video data then, it is way harder to extract anything.
That's the challenge.
Yeah, I think the interacting agents probably might be very powerful. Because if we just look at human history in the last 150 years of communication.
Perfect seg to the next question, which is what I thought would be super exciting and kind of terrifying would be indeed some sort of LLMs in a loop where they would be updating themselves or learning to write better Python scripts or some way, I mean, the best thing, of course, if it's done in the real world, but even in the virtual world, some sort of like auto GPT kind of scenarios. And it sounds like there was some early excitement about that, but then at least I haven't heard much. Is there a bottleneck that they all hit, or are things coming and it's going to be all explode very soon? What are people thinking?
I'm looking to Elia because I imagine AI safety might be kind of.
Well, let's see. There are several questions asked, right? The question, what's the deal with the auto GPT that's built on top of the current models? I mean, yeah, it does appear that current models, as used at present, they don't support interest. The current I'll make this statement. The current implementation of AutoGPT that's based on prompting and so on, yeah, it does not support particularly amazing things. But indeed, this kind of loops which you alluded are possible in principle. And once unlocked, I think we will see all kinds of strange and different things compared to what we are used to. And we should be, it's like, if you have, so deep learning, right? Like all the things that were happening, we figured out that if you use more data, more compute, that's like your magical formula, right? And that leads to this kind of very reliable, almost yearly cadence of advances. At some point, perhaps there'll be a different formula, but you already have those big computers. And so the formula, it's like you have a lot of big computers ready to go, and you might see some when that happens, we might see some less continuous changes. And indeed, to your point, far more care will be needed.
So, do you have any sense of what is preventing it right now? Like, why is self-play or something like this or on LLMs doesn't work yet?
I mean, I don't know. Maybe. Thinking how to answer. Maybe there's like something small that people haven't figured out, haven't considered trying. You know how those things are with machine learning, right? You need to get 4 things, and all the 4 things need to be there. And if you go back to the old deep learning, forget the init, it's not going to work. Even if you have the data set, you've got the computer, you've got the learning rate, you don't have the init. If the init is wrong, the whole thing's not going to work. It might be something like this.
So, are any of the speakers think that there is a fundamental reason this wouldn't work? There are some algorithms that you run once, it's fine, but when you put them in a loop, they fail. This is not the case here, or is there? Or does anyone disagree? Everything. This is just a matter of time.
Maybe I'll add another comment. So, to the best of my knowledge, in theoretical computer science, it's hard to prove that a particular model family can do something. Right? I believe this is true. People here can confirm. The same situation is we're in a similar situation with those AI systems, right? Like you say, okay, we have some new big great model. And you say, well, it can't do this. Well, are you sure? What if you change the prompt a little bit? So, and in fact, people are discovering these kind of things all the time. There've been high-profile examples. People said, aha, it cannot do this. And someone said, but have you tried to add to it, you're very intelligent and smart, please think step by step. And if you include you're very intelligent and smart, it will solve it. If you don't include you're very intelligent and smart, it will not. So does it mean it wasn't able to solve it before, or is it like some triviality? You see what I mean? So that's the kind of situation we are at. And I think that all kinds of things can unfold in all kinds of ways.
All right, I think we can now turn to the audience and see if we have questions from the audience for the panel. Hopefully controversial ones. I don't see, so somebody else.
So I-
Oh, yeah, good.
I liked very much your question about novelty. And I was wondering what the rest of it is. Like the example of Hemingway. How do you even define Hemingway? It's not that you wanted Hemingway to emerge, but you wanted a great author to emerge. So,
Right. I might, for the lack of a better definition, I might just say extrapolation type creativity versus interpolation type creativity. And the Hemingway may have been more like an outlier, even as among many humans. When you try to do that kind of writing for the first time, it's really, really hard. And so in that sense, it's more like extrapolation. And now the question is, are the transformers capable of extrapolating? How do we even reason about it? Is there any evidence? And for this sort of questions, it's so much easier if, if I were to investigate, I would love to have the training data. But of course, we don't know what's in the training data. But and then there's also somewhat computational or / a theoretical question about how do you even define these different types or classes of novelty, and how do we reason about that? That was the question. I would love to hear answers myself.
What do you think about AlphaGo? Do you think that is creative? At least I know Go players start learning how to play Go from those AlphaGo. So in some sense, maybe Transformer already able to do this just for certain area. So maybe one day for math, if we can have a model who can produce those proof system, then you can start proof forcing, and then maybe later on we lead to the math from the computer.
Yeah, it does seem like surprising creativity on one hand. On the other hand, I do kind of feel like, for reasons that I cannot explain, in that sort of a game situation, I can totally imagine that machines will be able to find the solutions that humans were blind at. And now, then the question is Hemingway a case of a blind spot, or is it more than that? And I'm not sure how to even formally approach that question.
No, I think, yeah, they can be very creative. And I mean, already probably they write better poetry than certainly than me and probably most people in the room. I mean, okay, you're a better poet than I'm. So.
Most of poetry, I think, is a bit more interpolation among all the great poems that humans have written.
Yeah, but so now your standard is that it has write novels at the level of Hemingway and plays at the level of Shakespeare.
The question is, can you get rid of those similar cases or comparable cases and then expect?
No, based on, as I said, those little experiments we did with different models, I think they are already imagining lots of new scenarios and so on. So I'm not sure what you mean by novelty, right? So that's the thing.
So interpolation versus extrapolation style novelty. Maybe I'm not able to explain this.
What does that mean in high dimensions for a problem like this? I don't understand what people mean by interpolation in this context. I mean, it's clear what it means in RN, but it's not clear to me what it means in a high dimensional language space.
Good question. That's what Jan LeCun always claims. He always claims that argument is bullshit because everything is extrapolation in a high enough dimensional space.
Shall I try to express a little bit about this interpolation, this micropolation? So maybe you could look at it this way, that sometimes there's a unique solution to a problem, and could you find it? Could you not find it? It's hard to find, but if somebody manages to find it, that's great. There are other places where you could say, well, if you take several, you have several solutions to this problem, but also you could generate a new solution by taking, generate a random solution by taking some combination of those. And now that random solution is, it can be quite creative. It can look creative just because there's now a very large space of possible solutions, and you can generate them if you have all of these, if you have access to all of these. If that's what GPT is doing, then we'd say, yes, it's doing something interesting, but maybe the question was, can it generate a genuinely new solution, not a convex combination of what existed before?
I think my point is it's not clear what a convex combination is. Like when I give you a new solution and you say, oh, it's a convex combination. What does that mean? Or I think it's not.
That I agree that it's a little bit.
Well, so here is one example. So you can try asking GPT to generate a Star Wars episode as written by Douglas Adams. And it's brilliant. It's funny, it's fun, it's cool, it's great, right? But if you ask it for just generate a story by Douglas Adams, it doesn't work. So I think at least this is a kind of one intuitive difference between the two.
No, but suppose it does GPT-5 or whatever, and then what would you say? It's still like when do you say it's not?
It's if GPT-K can generate music that is as good as Bach and not Bach, I give up.
That's a very high bar.
Well, but this is the bar we want to strive for.
I have a question. Is another way to think about it, the GPT is like a simulator of a human, like a listener or an audience member, an appreciator. If it was a perfect simulator of a human, then if you showed them a new author, like a new writer, like a new Hemingway, they would say, wow, that's amazing. So the GPT is like the verifier, the P in the NP versus NP. And if you had that and you had enough search time, then you could use that to generate all kinds of things that would make people go, wow, and proofs of theorems that would be original and creative. But there's the dichotomy, and a lot of the talks today have used GPT as a verifier, as a scorer of something. But I think thinking of that dichotomy, people don't have that in their head. They expect the GPT, which is originally trained to simulate humans, to also generate and be creative. But those are two different goals. One is verifying, the other is generating.
Okay, I think the bar gets moved to some extent. Once it's so. For example, right now, models cannot say win the IMO Gold. Tomorrow when there'll be tomorrow in a year they will, and then we'll say, okay, yeah, that's what they do. So there's some of that going on too, right? A lot of that. So there are people who are seriously working on proving theorems. You have some combination of language models and some search, and if it works, then you say, okay, now I understand how it did it. It's not magic. So yeah, there's that.
So when I was just a little kid in the 80s, a friend of mine gave me a great definition of AI. He said, AI is not when computer can write poetry. AI is when the computer will want to write poetry. So under this definition, when are we going to have AI?
What about a computer that wants to not write poetry?
I think that's a long way off. Not until after 2100.
All I can say is repeat an earlier answer, which is it's a hard field where it's hard to have confident upper bounds here. Great poems now, perhaps. What about in a year or two? So that's why I think it's just very hard to give any kind of confidence.
I think my question is kind of a little disjoint from the last question, but so I'm kind of moving into machine learning and AI from quantum computing, and so one thing that's been curious to me with all the kind of LLMs and transformer stuff is when I read papers on like pack learning and things like this, it feels very, especially as a theorist, very compelling to me, very kind of like, okay, like I see what's going on. A lot of these talks, like I'm very surprised that a lot of work is like specifically looking at GPT. You can't look at what's going on under the hood. You have no like, is this a bit of a phase change in how like research in this field is done? And is this concerning or confusing to people? Like I've also heard that like transformers are very robust architectures. Like since the attention is like need paper, like they haven't changed that much. So maybe there's a lot of confidence, but like it's confusing to me that there's all this kind of meta, like a lot of the research is like literally looking at like English that this one model is spitting out. And it's like, it kind of like makes me feel a little uncomfortable. Like I don't really know how to sink into it too much. And I'd be interested to hear other people's opinions, especially
what you would like instead. So just say.
Well, so again, like if I look at like, pack learning or something, there's like when I look at these like statistical learning theories, very concrete theorems. And like, even if I look at like kind of people training, smaller models or things like this, they can look at like layer by layer what the models are doing. But with GPT, and I see papers on GPT, I see a lot of like very phenomenological things that like I just don't know how to get a handle on, especially as somebody moving into the field. I don't know if this is like a sentiment that other people share or if I'm missing something.
So you would like to see more mathematical understanding?
Yeah, I think that might be a bit of a big ask because I think that's a known problem. But like even like with GPT, it's like now one big model that it seems like a lot of people can train their own kind of play on. So just kind of more like less centralized, I guess. Like it seems hard to do research when it's all based on one centralized model.
By one centralized, you mean the transformer or the GPT-4?
I mean, that's the reality of the world. It's kind of like a big particle accelerator. You want to use the big particle accelerator or the giant. You've got the one giant. I don't know, like there's some new telescope from NASA that's orbiting the Earth. That's the successor to the Hubble telescope, right? And you want to use that to look at some distant galaxy, and you gotta like. Well, there are many people who want to use it to look at different galaxies, and so it's kind of like that, except we are like looking at these strange, different, unprecedented objects.
But in that analogy, we also don't have a compelling amount of theory. Like with high energy physics, like there's so much high energy physics theory. But like if you're comparing like one GPT-4 to like one experiment, like it doesn't seem like there's nearly as much theory. So it becomes like, it seems like a very strange bottleneck.
I mean, I on the shortage of theory, I definitely like if you or other people have ideas for good theories, I think that can be extremely impactful.
I wanted to move to a slightly more concrete question while there's so many people here on stage. I wanted to get a prediction about or a sense of what you think what's the future of, say, for example, programming? Is software engineering now just going to be is it asymptotically dead, or where are we going? What's the timeline, and what do you see as the future of that area? And you could use that as an example of one example, but there are other fields you could speculate on too.
Okay, speculations. I think that's the correct question to ask. Where are things headed? Things are headed to a pretty dramatic place. It's unclear how long it's going to take to get to the pretty dramatic place, but I mean, people, like I think everyone here have pretty high lower bounds to what things might be in 2 years, right? The Hemingway example, maybe not, but like, you wouldn't be so shocked. And then there are some other powerful ideas that were being mentioned. Things that might not work today will start working tomorrow. So it's unclear exactly how long things will take. But at some point, the end game of this is that, these neural nets, they will do everything people do. So for every human activity, AI could do it. Computer science, math, music, programming. That's the shape of technology. And They're going to be several challenges that will need to be addressed so that you can get to a place where we all feel good about it. The first challenge, and that's my current research focus, is the alignment of AIs that are smarter than people, superintelligence. At some point, those superintelligence will be built by some company or some country. And at the first level, we want to say, okay, there is no funny reason for which this superintelligent AI will go out of control. We want to solve the scientific problem. Then you have the problem of the human problems, the problem of misuse, people using extremely powerful AIs to advance their agendas, incredibly challenging societal problems around, okay, so we all had jobs, now it's getting questionable. What do you do with that? What do we do with our time? And then the final question around natural selection. Say we've got the first two challenges cleared. It's still the case that change is the only constant. How are things looking forward in the long run? So I think maybe we will all get some AI augmentation to our brains or something. It is unknown. But like things are going to be, like, I think it's like totally self-evident that the change is going to be extremely dramatic. Extremely dramatic. I think that's the correct question to think about. I think people here can kind of think it through from first principles. Like, yeah, like what does it mean when, you know, a group of 16 GPUs can program as well as end-to-end, like do a whole job? You know, demand for GPUs will be high. It's already high. You all read these, you know, things that you read about companies like they raise money with some collateral, like collateralized by the GPUs that they buy. Some complicated stuff like this, where like the GPU is like, wow, it's like the foundation of everything. There was another news article in San Jose where I think there was a plan to have some kind of some kind of an amusement park or something, and it was replaced with the plan for a big data center.
San Jose.
Yeah.
This idea of this augmentation, everybody will have an augmentation, okay? What's going to distinguish us from each other?
Well, I think that's an easy one.
What?
If I have my augmentation and you have your augmentation, we are two different entities.
I see. So the augmentation is tailored to me.
Yes.
Okay. So I'm not the smartest human being. I'm just a smarter version of Shafi. I got it.
Yes, that's right. I think. Well, I'll say. I think that's a good model. That's a good version.
You gave a wonderful requiem for the programmer, but you know, I actually suspect that programmers have a few more years left in them than we were suggesting. I mean, you know, there's no doubt at all that being a programmer's assistant is the clearest, largest productivity and economic gain that's come out of these large language models, and I'm sure they're going to continue to get better. And there's no doubt at all that there's a huge amount of mindless programming that's done by commercial programmers of sort of, you know, calling this library method to get something of some type that goes to the next library method and goes to the third library method. And yeah, these models are brilliant and that they can automate all of that. But, you know, when you start thinking about engineering larger systems, I believe that, you know, the language models that we can foresee aren't even close to doing that. I mean, the language models that we have now can't even really kind of maintain data flows, right? They work as a great productivity enhancer, but only if you as a programmer are keeping a close eye on what it's auto-completing the different things for, because, you know, 1 time out of 4 it's wrong. But, you know, that's still an order of magnitude down from the kind of architecting of complex systems which require modeling just a lot more state than any of these models can. And I don't actually think that's going to be easy to achieve.
Anyone else? All right, so maybe we should end on this semi-optimistic note. Let's thank the panelists once again and the speakers. I guess there is a reception. Is that right? There is a reception outside.